If y is equal to x power cos x plus cos x power sin x, then find dy by dx. Let us consider the function x power cos x as u, that is u of x is equal to x power cos x, and v of x is equal to cos x power sin x. So that y is equal to u plus v. On differentiating, we'll have dy by dx is equal to du by dx plus dv by dx. So we need to find du by dx and dv by dx separately. So let us assume u is equal to x power cos x. Let us apply logarithm on both the sides. Log u is equal to log x power cos x, or we can write log u is equal to cos x into log x. By using the properties in logarithms, log a power m is equal to m into log a. Now differentiate with respect to x on both the sides, so that we can have 1 upon u into du by dx is equal to, applying uv rule, cos x into differentiation of log x is 1 upon x plus log x into differentiation of cos x is minus sin x. So we can write du by dx is equal to u times of cos x upon x minus sin x into log x. That is, du by dx is equal to x to the power of cos x times cos x upon x minus sin x into log x. Consider this is 1. And now we shall find dv by dx, that is v is equal to cos x to the power of sin x. Again apply log on both the sides. So we have log v is equal to logarithm of cos x to the power sin x. So this can also be written log v is equal to sin x into log of cos x. Now differentiating with respect to x, both the sides. So we have 1 upon v dv by dx is equal to sin x into differentiation of log is 1 upon cos x into differentiation of cos is minus sin x, and again plus log of cos x into differentiation of sin x is cos x, or we can write dv by dx is equal to v times of, so here it is minus tan x into sin x plus cos x into log of cos x, or we can also write dv by dx is equal to cos x to the power of sin x into minus sin x into tan x, or tan x into sin x, plus cos x into log of cos x. Say this is 2. So what is required? Dy by dx. So dy by dx is equal to du by dx plus dv by dx. So which is adding 1 and 2 will give the answer. So 1 plus 2 will give the answer. Okay. Evaluate integral 1 upon log x minus 1 upon log x whole square dx. So let us substitute or put log x is equal to t, differentiating with respect to x, we have 1 upon x into dx is equal to dt. When log x is equal to t, we can write x is equal to e to the power t. So we can replace here 1 by e power t into dx is equal to dt, our dx is equal to e power t into dt. Let us substitute in place of dx is e power t into dt. So our integral can be taken as integral 1 by t minus 1 by t square into e power t dt. And we know the differentiation of d by dx of 1 upon x is equal to minus 1 by x square. So it is in the form like integral f of t plus f dash of t into e power t dt. So which is nothing but e power t into f of t plus c is the answer. By using the property f of x plus f dash of x into e power x dx is e power x into f of x integral. So we can add here e to the power of t. E power t is nothing but x. E power t is x and f of t is 1 by t. So here f of t is 1 by t. So that f dash of t is equal to minus 1 by t square. So f of t is 1 upon t. 1 up t is nothing but x into 1 by log x plus c. That is x by log x plus c is the answer. Evaluate integral cos x upon sin square x plus 4 sin x plus 5 dx. We know differentiation of sin x is cos x. Let us substitute or put sin x is equal to t. So that on differentiating, we'll get cos x dx is equal to dt. So the numerator cos x dx we can write it as dt. So our integral can be taken as dt upon t square plus 4t plus 5. So which can be simplified dt upon t square plus 2 into t into 2 plus 4 can be written as 2 square plus 1. So which is 1 upon t plus 2 whole square plus 1 dt. Let t plus 2 is equal to some u. So that differentiating with respect to 2x, we have dt by dx differentiating with respect to 2t. So 1 dt is equal to du. So we can dt is equal to du. So our integral can be taken as du upon u square plus 1 can be written as 1 square. And we know that integration 1 upon x square plus a square is equal to tan inverse of x upon a plus c. So here we can write tan inverse of u divided by 1, that is u plus c. That is tan inverse of u is nothing but t plus 2 plus c, and again substituting back t is equal to sin x. So tan inverse of sin x plus 2 plus c is the answer. Find the particular solution of the differential equation dy by dx minus 3y cot x is equal to sin 2x, and given that when y is equal to 2, x is equal to pi by 2. So the given differential equation we can also write it as dy by dx plus of minus 3 cot x into y is equal to sin 2x, which is in the form of linear differential equation dy by dx plus p of x into y is equal to q of x, whose integrating factor is e to the power integral p of x dx, and general solution is y into integrating factor is equal to integral of q of x into integrating factor dx plus c. So let us find integrating factor for this given differential equation. So integrating factor is equal to e to the power integral p of x dx, which is equal to e to the power integral minus 3 cot x dx, which is e to the power minus 3. Integration of cot x is log sin x, which is equal to e to the power of log sin x whole to the power of minus 3. Or we can also write e to the power log 1 by sin cube x or cosecant cube x. And e to the power of log to the base e, we can write cosecant cube x by using the properties of logarithm. So integrating factor is cosecant cube x. And now the general solution, y into integrating factor, that is cosecant cube x, is equal to integral of sine 2x into cosecant cube x. Or we can write y into cosecant cube x is equal to integral sine 2x, we can write 2 sin x into cos x into 1 by sin cube x dx plus c. So we can cancel here sin x and here square. So cos by sin, we can write 2 times cos upon sin is cot x into 1 upon sin is cosecant x, which is equal to, we know that integration of cosecant x into cot x is minus cosecant x. So we can write minus 2 times cosecant x plus c. That is y into cosecant cube x is equal to minus 2 cosecant x plus c. And it is also given that when x is equal to pi by 2, y value is 2. So let us substitute y is equal to 2 into cosecant cube pi by 2 is equal to minus 2 into cosecant cube cosecant pi by 2 plus c. We know that cosecant pi by 2 is 1. So we can write here 2 into 1 cube is equal to minus 2 plus c, or we can write c is equal to 4. So the value of the constant is 2, so that we can give the solution as y into cosecant cube x is equal to minus 2 cosecant x plus 4. So y into cosecant cube x plus 2 cosecant x is equal to 4 is the solution. Find the general solution of the differential equation x minus 1 into dy by dx is equal to 2x power 3 into y. So we can write dy by dx is equal to 2x cube y upon x minus 1, or we can write 1 upon y dy is equal to 2x power 3 upon x minus 1 into dx. So 1 upon y dy is equal to 2 times of x power 3 adding and subtracting 1 divided by x minus 1 dx. So that we can write 2 times of x power 3 minus 1 plus 2 upon x minus 1, that is 1 upon y dy is equal to 2 times of a cube minus b cube is x minus 1 into x square plus x plus 1 plus 2 upon x minus 1 taken separately. So we have finally 1 upon y dy is equal to 2 times of x square plus x plus 1 plus 2 upon x minus 1. Now integrating on both the sides. So we have 1 upon y dy is equal to 2 times integral x square plus x plus 1 dx plus 2 times integral 1 upon x minus 1 dx. So integration of 1 upon y is log mod of y. Log mod y is equal to 2 times of integration of x square is x power 3 by 3 plus 2x square by 2 plus, we can write here integration of 1 dx is x 2x, and 2 log mod of x minus 1 plus c. So we can also write here, we can just simplify, since it is the question of general solution, you can leave the constant c. So 1 upon 2 log mod y is equal to x power 3 by 3 plus x square by 2 plus x plus log mod of x minus 1 plus some constant c, or log y square is equal to x power 3 by 3 plus x square by 2 plus x plus log mod of x minus 1 plus c can also be written. Solve the linear programming problem graphically. Maximize z is equal to 60x plus 40y subject to the constants 5x plus 6y is less than or equals to 45, 3x plus 2y less than or equals to 18, and x is greater than or equals to 0 and y is greater than or equals to 0. So let us consider the graph first. Since x is greater than or equals to 0, y greater than or equals to 0, the graph must be in the quadrant 1. First quadrant we shall consider, and 5x plus 6y, the straight line equation, less than or equals to 45. So let us consider the equation first. So dividing with 45, so we can write x upon 9 plus y upon 45 divided by 6 is equal to 1. So which is x intercept is 9 comma 0. So we can say 9 comma 0 is x intercept, and 15 upon 2, that is 7.5, that is 0 comma 15 upon 2 is the y intercept. So the straight line is passing through these 2 points, and another line 3x plus 2y is less than or equals to 18. So let us consider equation 3x plus 2y is equal to 18, dividing with 18 on both the sides. So we can say x upon 6 plus y upon 9 is equal to 1. So x intercept is 6 units, that is 6 comma 0. Let us write 6 comma 0 here, and y intercept is 0 comma 9. So 0 comma 9 is the point here. So we'll get a straight line passing through these 2 points. And coming to the inequality, in the first equation 0 comma 0, that is 5 into 0 plus 5 into 0 plus 6 into 0 is 0 less than or equals to 45, which is true. So we can say that the inequality will be towards the origin. And coming to the second line equation, even you can consider here 0 comma 0, 3 into 0 plus 2 into 0 is 0 is less than or equals to 18 is also satisfying, origin is satisfying the inequality. So we can say the shaded region is towards the origin. So we can draw the shaded region towards the origin. And here we can see that the shaded region, the common shaded region for both the inequalities is, which is marked by the points like O, A, O origin 0 comma 0, A is the point 6 comma 0, and say this is the B point of intersection of two lines, and C is the point 0 comma 15 by 2. So let us find the point B by solving the two equations. 5x plus 6y is equal to 45 and 3x plus 2y is equal to 18. So let's multiply with the 3, the second equation. So we'll get 9x plus 6y is equal to 54. So subtracting the first these two equations, so 9x minus 5x is 4x and 6y minus 6y is 0 and 54 minus 45 is 9. So x is equal to 9 upon 4. So the x coordinate is 9 upon 4 and substituting x is equal to 9 upon 4 in any one of the equation. So let us substitute x is equal to 9 by 4 in the first equation. So we can write 5 into 9 by 4 plus 6 into y is equal to 45, or we can also write 6y is equal to 45 minus 45 by 4, or 6y is equal to 45 times of 1 minus 1 by 4 is 3/4, or 6 times here 2 times, so 45 by 8. So we can write 45 upon 8. So x coordinate is 9 by 4 and y coordinate is 45 by 8. So we got the points. We can also consider this is the feasible region is bounded. The point and the profit function z is equal to 60x plus 45. First point 0 comma 0, substituting z is equal to 0 here, and the second point 6 comma 0, you will get z value 60 into 6 plus 40 into 0, which is 360. And next one 9 by 4 comma 45 by 8, we can say 60 into 9 by 4 plus 40 into 45 by 8. On simplifying, you will get, so 4 15 times, and here 4 2 times and 4 10 times, here 2 5 times, 8 5s are 40, 45 5s are 45 into 5 plus 15 into 5. So we'll be getting 45 5s are 225 plus again here 135, so which is equal to 360 again. And at the point 0 comma 15 by 2, we'll get 60 into 0 plus 40 into 15 by 2, which is 300. So at the 4 points 0, A, B, C, we got 0, 360, 360 and 300. We can observe that 360 is the maximum point at the point 6 comma 0 and point 9 by 4 and 45 by 8. Since the feasible region is a bounded one, and we can conclude that any point on the line joining A 6 comma 0 and B 9 by 4 comma 45 by 8 will give the maximum value. Any point on the line joining will give maximum value. Okay, so we can say that the maximum value, maximizing this function, will be obtained on the entire line equation passing through 6 comma 0 and 9 by 4 comma 45 by 8, that is 3x plus 2y is equal to 18. Three critics review a book. For the three critics, the odds in favor of the book are 5 is to 2, 4 is to 3 and 3 is to 4 respectively. Find the probability that the majority is in favor of the books. Let the three critics be A, B and C. So that it is given that three critics odds in favor of the book are given. Odds in favor of the book for three critics is given by For A, it is given 5 is to 2. Since they are odds in favor, so which is the favorable here and this is the not favorable. So we can write probability of an event A is equal to, we can say 5 divided by 5 plus 2, that is 5 by 7. Similarly, for B it is given, for B it is given 4 is to 3. So which implies probability of in event B is equal to 4 divided by 4 plus 3, that is 7. And for C it is given 3 is to 4, which implies probability of an event C is equal to 3 divided by 3 plus 4, 7. And probability of an event A is equal to 5 by 7, which implies probability of an event A bar is equal to, that is 1 minus 5 by 7, that is 2 by 7. And probability of B bar is equal to 3 by 7. And probability of C bar is equal to 4 by 7. And now the question is, find the probability that the majority is in favor of the books. Means probability, required probability we can write. Required probability is equal to probability of at least one, or we can say at least two of the critics, at least two of the critics review a book, which implies P of, we can say, A and B and C is not reviewed, or P of A and B is not reviewed and C, or we can write P of A is not reviewed but B and C are reviewed, or we can say that P of either all are reviewed, P of A and B and C. All the three are independent events here. So we can say probability of A into probability of B into probability of C bar plus probability of A into probability of B bar into probability of C plus probability of A bar into probability of B into probability of C plus probability of A into probability of B into probability of C. So which is equal to P of A is 5 by 7, 5 by 7 into P of B is 4 by 7 and P of C bar is 4 by 7 plus P of A is 5 by 7, P of B bar is 3 by 7 and P of C is 3 by 7, or P of A bar is 2 by 7 and 4 by 7 into 3 by 7, or all the three. P of A is 2 5 by 7 into 4 by 7 into 3 by 7. So which is equal to, so we can write, so 5 fours are 20, 24s are 80 plus 5 threes are 15, 15 threes are 45 plus 2 fours are 8, 8 threes are 24, and here 5 fours are 23s are 60 divided by 7 into 7 into 7 is 343, which is equal to 80 plus 45 plus 24 plus 60, which gives 209 divided by 343 is the required probability. So we can give the answer for this question is 209 divided by 343. Okay. There are 5 bags, each containing 5 white balls and 3 black balls. Also, there are 6 bags, each containing 2 white balls and 4 black balls. A white ball is drawn at random. Find the probability that this white ball is from a bag of first group. So let us consider here the two cases, like a first group and second group. And in the first group, there are 5 bags. And in the second group, there are 6 bags. So total we have 11 bags. And now again, in each bag we have 5 white balls, 5 white balls, and 3 black balls. And again in the second group, each bag contain 2 white balls and 4 black balls. And the question is, a white ball is drawn at random, means we need to select the white ball here. A white ball is drawn at random and find the probability that this white ball is from a bag of the first group. So our question is about the first group here. So that we can say directly here, selection of the first group is, its probability is 5 out of 11, and probability of selecting the second group is 6 out of 11, and probability of getting the white ball from the first group is 5 out of 8, and probability of getting the white balls from the second group is 2 out of 6. So we can say, according to the Bayes theorem, so we have 5 by 11 into 5 by 8 is the required one, upon the total probabilities 5 by 11 into 5 by 8 plus 6 by 11 into 2 by 6. So here 6 and 6 gets cancelled. So let us multiply and divide with 8 for calculation purpose. So denominator is 11 into 8. Here also denominator 11 into 8. So we can just go with it directly. So 25 in the numerator here, and here 25 plus 16. That is 25 upon 41. So probability answer is 25 upon 41. Or if you want to write the steps here, we need to consider E1 is the event selecting the first group, and E2 is the event of selecting second group. So that probability of an event 1 is, total number of bags is 11. So probability of E1 is 5 by 11. Probability of an event E2 is 6 out of 11. And now let us assume that E is the event selecting a white ball. Selecting a white ball. So that we can write selecting the white ball from the first bag. Selecting a white ball given from the first group, which is nothing but, we can say 5 out of 8. And probability of selecting a white ball given that it is a second group, which is nothing but 2 out of 6. Now the question is, we need to find the probability the white ball from a bag of the first group. Finding the probability that this white ball is from a bag of the first group means, given white ball we need to get it from the first group, that is E1. Probability of E1 by E, which is equal to P of E by, you can write P of E by E1 into probability of E1 divided by probability of E by E1 into probability of E1 plus probability of E by E2 into probability of E2. This is by Bayes theorem. So that we can just consider
The answer is 5 by 11 into 5 by 8 upon 5 by 11 into 5 by 8 plus 6 by 11 into 2 by 6. After calculation, you will be getting 25 by 41. So 25 upon 41 is the answer.